Looks like we are live here. I'm here with David Weis from Meridian Construction, and wanted to basically talk to you a little bit today about your business, what you do, and kind of what sets you apart from the other million custom home builders here in the Louisville area.
Well, in terms of energy efficiency and performance, I think there's probably maybe a little longer history with the building science and the development and some of the minor things that we've been doing to the envelope for years to try to tweak these houses and just make them the most energy efficient without breaking the bank. So I would say the biggest difference between myself and a lot of very good custom builders too would be trying to develop that envelope on a budget. And I hate to use the word budget, but trying to be very cost sensitive and still yet turning out a very efficient product.
So now when you say envelope, I think a lot of people don't really know what envelope of a house means, but the envelope of a house, for those who don't know, is basically the enclosure, the outside kind of walls and ceiling and the windows and all that kind of stuff. And there's a bunch of different ways that you can create an envelope in a house. And what's the way that you like to do? What's kind of your preferred way of materials that you like to use?
Good question. And it's only because we've started this particular way, and there has since been some development of other ways, but we've stuck with our original program and plan. We use a lot of plywood and OSB board on a lot of the common attic wall spaces. We use a lot of lumber in our framing. So my preferred way, and I'll just use a bonus room for example, because I think the bonus room, which is a room that's above the garage, middle of the summer can be sweltering hot, in the middle of the winter it can be freezing cold. So so on the common wall, meaning the wall that is on the other side of that wall is the attic space, we will line that with plywood. And we line that with plywood to prevent air from getting into that insulation cavity. So that would be the most common material that I would use. There are some guys that use house wrap. There are some guys that use foam board. There are some guys that use maybe the thermal board, possibly. So all of which I think would probably be pretty successful. But our preferred product is still wood.
So with the plywood, obviously there's more of a structural component to that. It doesn't necessarily have the highest R value, but it's a common material to use. So there's nothing wrong with it. So it's, we're talking about basically what separates the attic from the inside of your living space to make you more comfortable. And that wall that he's talking about, a lot of times you'll have a story and a half house, and you've got a lot of these walls that face attic space, or you've got a room above the garage, and that's called a bonus room. At least two of those walls face attic space, and those rooms are usually pretty hot if they're not insulated and built properly. So in addition to the type of sheathing that you're talking about using, what types of insulation products do you prefer to use, and have you used in the past?
So that's another good question, because it's my feeling, and maybe you would agree, maybe you wouldn't, but the energy. So I think it all starts with building the correct envelope first. I mean, you've tested some of my houses, and we have received energy efficiency and a very good HERS index score, which is how you rate a house. That's how the houses are typically rated in terms of their efficiency with every type of insulation we've used. Foam, we've used batt, fiberglass, bibbed cellulose, stabilized cellulose, bibbed, and bibbed fiberglass. So we have gotten a very, I built to what I would consider to be an Energy Smart 2.5 is typically the standard that I try to go for, which I believe, you can correct me, is the old Energy.
Well, so there's Energy, so just to clarify, for people watching, so there's Energy Star certified homes, and then there's Energy Smart. And Energy Star is kind of what people have thought of in the past as an energy efficient house, and it's promoted by the government, whatever. The whole Energy Star program really changed big time back in 2011, 2012. And I think they really kind of raised the bar to a point that was not cost effective for a lot of builders to work with. And it was really difficult to get the HVAC contractors to do what was required by that program. So ResNet, which is the Residential Energy Services Network, which I'm a part of as a HERS rater, created a secondary program called Energy Smart Homes. And that is basically a code-built house and a little bit above, and there's certain, prescriptive things that they want you to do. So most of your houses I would consider the energy smart homes, and they're definitely above code level. And there's a lot of different ways that you can get to an energy smart house, but when we do an energy rating on a house, it's usually between a score of, say, 40 and 70 on average. I'd say in the state of Kentucky, mid 60s is kind of the average score for most
That seems
homes.
right.
Yeah. And you can get to it, like you said, by doing fiberglass insulation or cellulose or spray foam. But there's a lot of different things that go into effect. And so basically, the lower that score is, the more efficient that home is supposed to be. It's kind of like a miles per gallon sticker, projection for your house. And so, whether you're using fiberglass or foam or cellulose or whatever, you can still get to a really good HERS index score number. Do you happen to know what the lowest number is that you've gotten recently?
Without using geothermal and foaming, I would say probably a 51, 52 range with conventional products.
Yeah.
So very, very, very tight, very
Yeah.
high efficiency.
Yeah, so that's pretty good. There's actually a whole nother kind of additional program that's basically like it's a net zero ready house.
Mm-hmm.
And typically what they want you to do is shoot for a HERS rating that's kind of around that 50 mark.
Mm-hmm.
And then you add solar panels or you add
Mm-hmm.
geothermal or both.
Yeah.
So what's kind of one of the misconceptions that you run into when you're talking to a new homeowner who wants to build a new house and they've got some questions about, insulation or HVAC or whatever? I'm sure there's kind of the same questions come up.
Well, it is the same question, and it all goes back to, for the general consumer to evaluate or consider an energy efficient home, they think one term and one term only, and that's what do you insulate with. And
Mm-hmm.
and my great my response to that regularly would be the insulation is very important,
Mm-hmm.
but the insulation can be rendered very ineffective if you build a poor quality envelope. Okay, so and I'm going to give you an example of that, and I try to educate my clients as in layman's terms as possible, because we all know that we can geek out on this for the next 2.5 hours and spend thousands.
It'll just go straight over
right.
there.
I mean, so you try to just funnel this into and package it up to where they can understand it. So let's just say somebody's always cold in their car, and they go buy the best car with the best heater, okay, because they're always cold. They're going down the street, it's 20 degrees and the heater is blasting, but it's still cold. It's because everything that you're putting into that car is leaking right out the window. So even with the best insulation, we still have to make sure we keep that thermal energy in, okay?
Yeah, keep the air inside the house.
Keep the air inside the house. So for me, I try to really kind of bring it around full circle to my clients. Like, okay, I can get you that very efficient home with a very, very cost-effective insulation component if we manage the envelope well. So it takes a little bit, and if we can stop, and you know this term very well, thermal convective properties, how air moves through a house or gets to the insulation. So I try to strip it down into, let's take care of the envelope first. Let's make sure no air gets to the insulation, rendering it less effective depending on the insulation, the product that we're using. And let's start from there. And we're in a house right now. This house is probably 3,700 feet, 1 HVAC, 5 zones. And I have it on my phone. I haven't looked at it, but I can, I track my energy consumption on the heating and cooling side. But I have no foam in this house. So this house is
Did you do a blown-in product in this house?
I did a blown-in product in this house. So I did a bibbed blown-in cellulose for the wall cavities. We then did an unstabilized cellulose for the attic space.
Okay.
We did a very good air infiltration package, which for those of you who don't know, we literally go around every nook and cranny of every crack and opening that air can get into the house, and we seal it up with foam or latex caulking to stop that air infiltration. So, and we've been in this house now for probably 16, 18 months. And, it's like, it's like, hot butter, man. It's really just a very smooth operating, very quiet.
You don't have hot spots or cold spots.
No,
the house. Even temperatures.
We don't. It's very even, and we have even a large. You can see we're in a room right now. On the other side of this camera, there's like 6 or 7 windows, and it's just a lot of glass, and there's some thermal loss with that. But even in this space, with all the glass, it's extremely comfortable.
Yeah, I like to tell people that are thinking about building houses, even if you want to use fiberglass bats, which is probably the worst insulation product out there, you can still build a tight house with fiberglass and make it comfortable, but you have to make sure you air seal it first. So fiberglass doesn't stop any air from moving through it. It's the exact same material that's in your furnace filter. I call it filter glass. But if you air seal the exterior part of the house first, the sheathing to the framing, all the electrical penetrations, the plumbing penetrations, anywhere where something goes outside of the living space, if you air seal that first really well, you could use fiberglass or cellulose, and it's still going to be significantly tight. However, the other thing that a lot of people don't think about, when you've got traditional construction, it's got drywall, it's got stick-built framing, the space that is actually between the top plate of your walls and where the drywall connects, there's little gaps between that drywall and that framing. And air actually moves between that framing and that drywall, believe it or not. And it's not something that anybody would ever think about unless you'd seen an air leakage test done on your house with an infrared camera.
Exactly what we're talking about.
So if you use cellulose in your attic or fiberglass to a greater extent, and air will easily move through that fiberglass behind the drywall and the framing. And so even taking the extra step to air seal the framing to the drywall on the attic side before all that insulation is blown in will make the house really, really tight. So maybe you have a customer who wants to put fiberglass in the walls, but then they pay a little bit of extra money to seal.
Kind of gasket.
Yeah, seal the lid is what a lot of guys call it.
It's so simple to do as well when you're in that stage too. These things that we're talking about.
It's the best opportunity.
Well, and it's accessible too. You can get right up there, and in a decently sized home, you can do it in 45 minutes. You know what I mean? It just doesn't take a lot of time to do it. So, but yeah, I do agree with you.
But rather than coming in after the fact, you've already built the house, you've already spent the money, and then figuring out later that you've missed these opportunities, it's a lot more costly at that point to fix it at that point in time. So I know you wanted to talk a little bit about geothermal systems and maybe heat pumps and furnaces, and you probably get questions about those kind of things. And
well, as it relates to my homeowner, it's always a hybrid system. What's the difference between geo and a good conventional system? And we're putting both in right now. And all systems, when installed into a house that's built well, performs better. It's just amazing how much more mileage you get out of your components in terms of its effectiveness when you have that good envelope. So we're building Norton Commons right now in the North Village. It's all geothermal over there. So we've had very fortunate to have had great success with the geo system. But again, we're always trying to meet the client's expectation of pricing. So you just have to be sensitive, and you got to have a good backup for geo.
Right.
Because we do understand there's still a tax credit, I believe, that's been extended. For the geo, it's 30% of the product. I believe you get as a dollar for dollar credit, and that does help. But it's still, it's still hard to compete with some of the higher end conventional products in terms of price. So we use both. So I have Geo, and then I have a lot of the Carrier brand, the Infinity system as well, on a conventional side, which is a non-geothermal. We use that and been very happy with that. Staging becomes critical in these houses, and I think regardless if it's geo or even a higher end conventional.
And we're not talking about your furniture staging and the
That's
decorations.
right. We're talking about the staging of airflow, essentially how much air is delivered into particular zones. And again, without getting crazy geeky on this, this is the balancing act of relative humidity, comfort, and energy efficiency. And it is a balancing act.
So when he's talking about staging, it's kind of like, most furnaces or heat pumps have like one stage of output, and it's either the blowtorch is on or it's not. And so if you have either two-stage or multi-stage systems, you can have 1, 2, 3, 4, 5, or a completely variable output system. So if it's, if it's 60 degrees outside and it's a little chilly, it'll be on the lowest stage of output. And so it only has to work a little bit to make that house comfortable.
That's right.
If it gets down to 15 or 20 degrees outside, then it goes to one of the higher stages of output.
Grabs that next gear.
Yeah. So it's kind of like having you have a Tesla and it's got a variable speed, motor and transmission.
Yeah.
And so it just puts out the amount of energy needed to make it go for however fast you're trying to go.
There's a lot of benefit to that too, outside of energy savings and comfort. I mean, it's very quiet.
Yeah.
And this is our house, and we have that system in our house, and so as an experiment, because I'm always experimenting, especially with my own things before I do it on my client's house. We set up our conventional system, and we have a 5-stage air conditioner in this house.
Wow.
So when one of our zones, let's say it's the kitchen zone, is calling for cooling, it typically starts in stage 1, which is using the lowest energy consumption, the
low airflow.
You can't even hear it.
Yep.
You don't even know it's on.
Yep.
So, and with with a tight house, many homes that I build live in stage 1, 2, and 3 for 95%
Right.
of its existence. So, so that being said, if we're only using 20% of the capacity of the equipment, we're consuming essentially 20% of the energy as well too, because it's a variable speed.
Right.
It can only generate and push out what we're using, so it does save a lot.
And it really does become pretty critical that your heating cooling contractor understand how tight you're going to make the house and how you're going to insulate the house so that they can actually size the equipment accordingly. Because most HVAC contractors in the past have just kind of taken a rule of thumb method, and they said, well, this is a 3-bedroom house and it needs 80,000 or 100,000 BTUs and 3 tons of air conditioning or whatever it might be. But when you really start making these houses tight and insulated really well, it's surprising how low those loads can get. I mean,
it's amazing. This house again is 3,700 feet, and that is for everything on the first floor and the second floor. So I went into my system and my central stack for my HVAC, and what I did is I kind of essentially tricked my system into thinking it's about an 1,800 square foot house. So what I'm doing is I am limiting the amount of airflow. I stopped it so it can't even grab the next gear. So as an experiment, I'm making my thermostat think that we live in an 1,800 square foot house. So what I did is I put zoning limits on it. So I cut the CFM that was needed for this space. Let's say it's 800 CFM of air for this space. That was done on the test, airflow test for the equipment. Mm-hmm. And then I'll put a limit, I'll put it on lowest setting, and it'll say, okay, we're only going to deliver 400 maximum CFM to this space. So I've really cut it down just to see if my house can hold up in extreme conditions.
It probably does.
It did.
Yeah.
So, if I'm only, immediately I'm on the phone talking to Carrier, and I'm like, if I'm only, running at this lower capacity, this lower CFM, how much fuel or energy am I burning? And it's only going to burn or use what it can put out. Mm-hmm. Okay, there is no excess of energy that's getting dumped back into it's not like a bypass.
Yeah.
So
you said this house is what, 3,700? And what is I'm just curious, what's the maximum output of your air conditioner that you installed here?
The maximum output, I can only relate it to the zones because it's a 5-ton system. Okay. By the way, it's a 5-ton system that is on the air conditioner side. It is a 5-stage system. Okay.
So does it ever get out of the second stage of output?
I have seen it in the heat of summer when the bonus room, which is the most difficult area to cool in the summer months. And it was hot summer. I mean, it was
95 degrees.
It was 95 degrees forever, and I miss those days. I love the heat. So, but it did reach into stage 4 and 5 for a very brief period, and you could hear it. The only reason why I knew that it had touched into those higher stages,
it got louder
because you can hear the airflow. That's right. So, but until then, no, and since then, no.
So I always tell people if you don't have like a multi-stage output system, and for example it's 93 or 95 degrees outside, you can actually time the amount of time that your air conditioner runs, and say that it's running for 20 minutes out of the hour and it's 95 degrees outside. If that system was actually sized properly, it should run for the entire amount of that hour. So essentially you could say that if your system's only running 20 minutes out of 60 and it's supposed to be sized properly, it's obviously not. It's about 3 times bigger than it should be for the size of the house. So most older houses that are built today or that have been built in the past will have these bigger systems, and they'll only run for 5, 10, 15, maybe 20 minutes at a time. If they run for 45 minutes, 50 minutes, 60 minutes, that's actually good, because the longer that air conditioner runs, the more moisture it's going to pull out of the air, the better dehumidification it's going to give.
That's totally the case too, and it's short cycling, and all about short cycling. So running it longer at a lower speed is
more efficient.
Is vital. It's way more efficient, do you know? And I don't, and I didn't. The efficiency of an HVAC system, the approximate efficiency right when it fires up. I've been quoted some figures, but
I don't know if there's a blanket number that you can put out there. I mean, it can be tested. You can test the airflow through it and the heat rise or the cooling drop,
Sure,
and kind of figure that out. But what have you heard?
Probably low 40%. So immediately when it first starts, that first 30 seconds, maybe a minute, or depending on the equipment, obviously.
Yeah.
But it's so inefficient.
When it first kicks on.
It's equivalent to if you start your car up and it's cold outside.
Just let it idle forever.
Well, if you start it up, put it in gear and go 80. You know what I mean? That first 3 or 4 miles is going to be very inefficient because the fluid's not operating at its maximum. It's got to get going.
Right.
So by having these systems run and cycle longer, it's been my understanding and feeling that, just like what you said, if we can fire them up, run them at a much lower energy consumption length and period,
right,
and have greater control over the indoor environment, because you lose all control when the HVAC isn't on.
Yeah.
Okay. But running it slower and longer, dehumidifying those houses. This house will run probably in the 47, 48% relative humidity range.
That's where you want to be.
In the heat of summer, you know what I mean?
Yep.
Other houses that may not be set up correctly will be 8 to 10% higher,
Well, I've seen houses in the 60s and 70s this summer, and it's, they're short cycling big time, and they've got leaks through the envelope that we talked about. They've got duct leakage. Maybe you've got ductwork in an attic, and there's air being sucked in through the return ducts, and that attic's 130 degrees.
Filled with humidity. So in cycling them longer and slower and without getting all super geeked out, the comfort level is just crazy. For those that have dry skin in the winter months, it's not as uncomfortable.
Sinus issues,
bleeding,
you name all that kind of stuff.
And it's kind of weird because when you're coming in from outside into this house and it's 72 in the middle of summer, people think it's 65 degrees in here because we have less humidity in the air.
Yeah.
So the comparison or the translation of humidity to temperature, as I understand it, and you can correct, I might be wrong on this, but 20% in relative humidity feels like 3% in temperature to the skin. I could be wrong for saying that.
I always tell people you want to be somewhere between 40 and 50% relative humidity if you want to be comfortable. The lower the relative humidity, the more uncomfortable typically you're going to
That's
be.
Right.
Especially in the wintertime.
Crazy.
In the wintertime you actually want maybe a little bit more relative humidity. You don't want that dry heat. And in the summer you want less relative humidity inside the house. And if you have less relative humidity in the summertime, you can put that thermostat at a lower temperature and still be comfortable.
You mean higher temperature?
In the summertime.
Yeah, you can put it at a higher temperature because we're running less humidity.
Correct. Yes.
Yeah, so 72 feels like 69 in this house. Literally, because it's 2 to 3 degrees warmer in the house, but it feels cooler because of the lack of humidity.
Yeah, like in my house, I've got 2 systems, but one's a 2-speed variable 2-stage variable speed system. My relative humidity in my house is always between 45 and 48%.
No, that's great.
And I set my air conditioner to 75 degrees
There you
in
go.
the summertime, and I'm perfectly fine.
Feels great.
So,
So I think that's right. You know, as when people talk about energy efficiency, they only think of dollars, by the way. So, and I try to educate my homeowners. I'm like, it's not just dollars. It's like literally, it's comfort every day.
yeah.
I mean, it's every day feeling comfortable in your space. Not only are you saving money, but you feel better about it.
To a lot of people, it really is more about the comfort and the indoor air quality of the house. And when you have some of these oversized systems in a leaky envelope or a poorly insulated house, you start having other problems with mold and mildew growth and a lot of other things that you don't want to find in a brand new house. So I'm sure you probably take some extra steps to make sure that you don't have those issues. I don't know if you want to touch on those at all.
We don't have those issues, and a lot of this does, circle back to the HVAC contractor. When we first started doing this, our first Energy at the time, it was Energy Star, was in 2006, and we've just been developing our own little intellectual property since then, in order to really get this thing up and going. But we really had to work with the HVAC contractors because they were consistently sizing these things at a very too big. It was just really like twisting their arm.
Too conservative.
They were like, they were basing it on an envelope that was leaky. They were basing it on ducts that were going to leak at a certain percentage. And this is how they had done it for 30, 40, 50 years. The old adage is if you're cold, go turn the heat up. It was very, very simple.
Yeah.
And that was cool. Energy was cheap, back then. And, so things are changing right now and have changed. So we really did struggle with our HVAC contractor in getting that right and really convincing them that the loads that we were providing them were accurate. And even today in some of these neighborhoods, the neighborhood that I live in, there are several of my homes that are 10, 12 years old, that there are these large 2-story homes, okay, and there are 33, 34, 3,500 square feet, and there's one compressor on the outside. Even today, people still haven't gotten on board. It's just kind of a weird.
Why isn't there a second system in the attic?
Why isn't there a second system? I can't believe this is. I've even taken people in a house in the sweltering heat of summer that I'm showing them as it's being built because we're working on, building them a house and we're in the designing process and they wanted me to set existing projects that we have going on.
Yeah.
And even taking them to that space.
Just showing them.
And showing them the.
Proofs in the pudding.
And it's 68 and you can almost see your breath, and it's 98 outside there. As you're designing their home, they're still concerned. Now, are you sure this is going to work in my house? I mean, it's like this big voodoo curse that somebody casted over all the HVAC community. I don't know what it is, but it really does work, and it works very well when handled correctly.
Yeah, and the handling correctly part that we've really kind of tried to emphasize over the last few years is that you can put the most expensive, fanciest box, whether it's a heat pump, geothermal, or furnace in that house, but if the ductwork that's connected to that box is not sized properly, is not designed properly, it is not going to move the airflow through the house properly, and it's not going to be as efficient as it should be.
That's a fact, and I got to tell you that I will give kudos to not only guys like yourself. There's other raters out there other than you. I do use your service. I'm very happy with your service. I will say that for our space though, and the education and how we've caught up, we've done a very good job with our building science locally. At least I think we have.
I think you're doing a good job.
Because in terms of education, I was somewhere south this past a couple of weeks ago on fall break, and I'm walking through these $4, $5, $6, $8 million homes, and they're having humidity issues, and they just don't know how to balance the envelope. And there's these weird houses, they're all concrete, and there's this humidity level that's constantly like attacking them, and they're really struggling to manage the envelope. And I think that I appreciate the education that we've gotten.
Yeah.
And I think we are so far ahead of the curve for being such a southern community and region that it's really good that we've come this far.
I can't tell you how many $1 million plus houses that I've been into that have just the crappiest heating cooling systems installed in them, and it's just, they would rather spend the money on quartz countertops or their super crazy design inside the house, and it's like, this is important too, and you really need to pay attention to how that's put together and designed if you want to be comfortable and happy in this nice new house that you're designing and building. And
it becomes a tough sell because you really can't put your hands on it.
It's intangible.
It's intangible, and and I share with all my homeowners. I'm like, you're going to have to live in this house to understand it. Mm-hmm. Now, the callbacks that I have received from my homes failing thermally over the last 230 houses has been almost zero.
Yeah.
I mean, I just have zero callbacks. You know what else I have very few callbacks on is the trim as it expands and contracts as it goes through season.
And
I don't have to fix all the, go in there and recall
all
of it, because we have a balanced relative humidity because our home is balanced.
Yep.
So, I mean, it just leads, again, outside of the energy efficiency. The benefits of the home and the envelope when handled and managed correctly I don't even know how you calculate it. I mean,
it's intangible, but to me, and I'm sure to you as well, it's really part of the quality control process of this house. Controlling where the moisture comes from, controlling the moisture that you create inside the house so that it gets out
negative
of the house.
Pressure,
or providing some kind of fresh air intake if it's necessary. But there's all these things have to go into consideration, and if you don't work with a builder, here like Dave, that's taking all these things into consideration, you could end up with a product that's fallen apart within a couple of years, mold growing in it,
it happens.
Trim cracking, gaps between framing and stuff, and it's just really unfortunate, and it's super preventable. So,
but it comes with an education, and it comes with reaching out to people who know, and and as we're talking about all this fancy equipment, we can also talk about the zones. So I don't know if in fact that you have, and I know you're familiar, but some of the buyers and some of the folks that might watch this are not. When you zone a house, I mean, I think it's something that we should probably talk about, right? Zoning?
Yeah, I mean, so here's my take on zoning. Every builder's a little bit different, or everybody's got a different opinion. My opinion on zoning is if you spend the extra time and money on air sealing the house and making it really well insulated, and you design the duct system properly, zoning is not as important.
I agree.
If you have a poorly designed house that's leaky, that's when people want these zones to offset for this room's really cold or this room's really hot. I need to send the temperature over here or over here. Now zoning can be really a really good thing, but I think it's less important when you do all the extra stuff right.
I agree with that. And when we get to a larger footprint, let's say for a ranch, if I'm building a single story house with a finished basement, I do no zoning. Yeah. So because
it's simple,
so we like never zone that. Now, if we have a basement that's 2,300 feet and then we have an upstairs that's 2,700 feet and we're sharing capacity, if you will, with one system, then I might consider zoning. I think zoning becomes a little bit, for me and from my experience, a little bit more important, even with good ceiling, is when you add a second story.
Sure.
You know what I mean? I think you're
or
a little
bonus
bit.
Room or whatever.
Yeah, the bonus room is it's kind of disconnected from the principal envelope of the house, and if you think about the bonus room, it has basically the underbelly of the bonus room is an unfinished space. It's the garage.
It's the garage.
You leave the garage door open. It's 95 degrees outside, and it's 95 degrees in your garage. So. So the bonus room is really kind of a peninsula. It's on its own. So that becomes a little bit more critical. But if you do have any kind of zoning, going back to the staged equipment,
it's even
critical.
Yeah, absolutely.
It's a must. And
yeah, you can't have single stage equipment on a zone system. It just does not work.
I've seen it.
You can do it, but it sounds like an airplane taking off every time the system turns on, and it's not a good thing. So.
They bypass is what it is. A lot of times they do that. They
bypass dampers on.
Yeah, they put the bypass, so you're basically spending all that money on the energy and dumping it right back in the return.
Yes,
so,
I mean if you have a house that only has a normal furnace on it or whatever, and it's got say even 2 stages. If they close one of those stages, it's trying to push 100% of the air through half the ductwork.
That's right.
And it just sounds
it sounds like a jet taking off.
Yeah, it sounds awful. It doesn't work very well. So,
but you do see it. I mean, I have seen it, and I've seen people try to correct it with bypass and other techniques like that, which are it's a very bad idea.
It's kind of a band-aid to the solution.
Yeah.
Really, the equipment needs to be, like you said, 2-stage, multi-stage, or whatever.
It does, but there are benefits to zoning. For us, we have this house is kind of split up, and we like our master in the at night we sleep with it a little bit colder, so it's kind of like nice to be able to do that.
Yep.
And, so it's a convenience
Not
issue.
overcool the rest of the house.
That's right, and not hear it too. So that's the benefit of it.
So is there anything else you kind of wanted to touch on today as far as what you like to do different or anything?
Starting the education on solar with the backup battery. I know we have actually had some conversation about that. I mean, that's probably going to be for another vlog, another video here. But I mean, it's I'm really excited about solar and the ability to capture, harness, store the energy, and then use it
for your own purpose
when you need it. So instead of solar, typically you bring it in, you got to use it. So I'm looking battery storage. I think is the net as what I'm really excited about.
Yeah, we'll definitely have another episode about that whole solar, electrifying homes completely. No gas appliances. Some people still want to have the gas range, and there's a whole argument about that as well. But I definitely want to talk about that at some point in time. And
it's coming.
Yeah,
I mean, it's on its way.
So
I would like to say that energy costs. Check your energy costs. So I don't know if you've done I talked to David in your office, and one thing that it's hard for, not really hard, but I really lose sight of is watching the increase of energy costs, and I just calculated my LG&E bill, my energy bill.
Yeah, it seems to go up a little bit every year.
It does go up a little bit every year, and I was calculating it and I just take my overall consumption versus price, because there's a lot of taxes and fees and surcharge and there's a lot of things attached to that per kilowatt hour.
Right.
So I'm curious to see what David comes up with, but my calculation, it's gone up, 6, maybe 7% in the last couple of years, maybe more.
I know when I started the business back in 2008, I think we were in the 6 to 7 cent a kilowatt hour range.
That's right.
And now we're more like 9 to 10.
I think it's a tick over 10 now. If you add in all of the environment,
all the fees.
And I'm coming up with 10.314. So it's
so your number pretty
well. That's just what I came up with, my simple math, but it's over 10.
And we still historically, compared to the rest of the country, have really low electric rates. But they're not getting any cheaper, and it's something to consider going forward.
But in 10 years though, from 2008 until 12 years, almost now 12 years. I mean, you said it was about 7 cents a kilowatt hour, and
6 or 7, and now it's at 10. So
okay, so that's almost that's over 40%
increase.
Okay,
another 10 years, it'll be 14 or 15%.
So, and you don't hear it's such a slow bleeding process of increase that you don't. They've done a great job.
Just kind of sneaking it in
there.
They
do.
Letting the PSC know every year that it's going to happen, and they have
to
sign
never goes
off
down.
on it. And it's definitely
it never goes down. It's not like buying fuel at $2.80 one week and then it goes to $2.40. It's constantly on the rise. So anyways.
Well, I really have enjoyed the conversation. I definitely will have another conversation with you about maybe solar and batteries and some more advanced stuff. But appreciate you being on with me today.
Thank you. Thanks for having me.
And I'll definitely talk again. See you guys.